Okay, so section 1.8, exercise 99 and 100. The graphs of f and g are shown. F is the blue, g is the pink. Evaluate the function at the given values of x, if possible, and write your answer as integers or simplified fractions. Select undefined if applicable. So f plus g evaluated at 1 is the same thing as taking the function f evaluated at 1 and adding the function g evaluated at 1. So we're going to go to our graph. Let's use our highlighter. So we're going to go to graph and find f of 1. So x is 1 on the f graph. It's going to be that value. And then g of 1, we're going to go to the pink graph and evaluate at 1. It's going to be that value. So let's go back. F of 1 is 1. So we're looking at the value of y when x is 1. So that is here. And then we're looking at the value of y when x is 1 for the g function. So that's going to be 1 plus negative 2, which is going to be negative 1. Okay, so let's clear our graph here. And let's go back to the next one. So g minus f evaluated at 0 is the same as g evaluated at 0 minus f evaluated at 0. And g evaluated at 0, g at 0 is the pink, is here, and f evaluated at 0 is here. So g evaluated at 0 is negative 3, and where am I subtracting? And f evaluated at 0 is 1, and negative 3 minus 1 is negative 4. Okay, clear our graph. G times f of 2, that's g of 2 times f of 2. So g of 2, g is the pink function, evaluated at 2 is going to be negative 1, and f evaluated at 2 is going to be positive 2. So we have a negative 1 and a positive 2. So g evaluated at 2 is negative 1, and f evaluated at 2 is 2, and 1 times negative 1 times 2 is negative 2. Okay, let's clear our graph. Now we're doing g divided by f evaluated at negative 2. That's g of negative 2 divided by f of negative 2. G of negative 2 is going to be negative 1. And f, the blue function evaluated at negative 2, is also negative 1. So we have negative 1 divided by negative 1. And negative 1 divided by negative 1 is 1. Okay, let's clear our graph. Now we have at the composite function f of g evaluated at negative 1. That's the same thing as taking the f function and evaluating it at g of negative 1. So the first thing we need to do is find g of negative 1. So g is the pink function, evaluated at negative 1, it's going to be negative 2. So this is going to give us f evaluated at negative 2. So now we're going to find f evaluated at negative 2. So f at negative 2 is going to be negative 1. So we took the function g, evaluated it at -1, and found the value -2, and then we took that value and evaluated f at -2 to find the value of the composite function was -1. So it's a two-step process. Now let's see if we can do the same thing with the next one. So the next question, we're doing g evaluated at f of -4. So we're going to take the g function, we're going to evaluate, let's go back to blue. So the g function, and evaluate that at f of -4. So the first thing we need to do is find f of -4. So we're going to go to -4 and f of -4, whoop, I need my f of -4 is -3. So the f function is the blue function, and f of -4 is -3. So now we're going to find the g function evaluated at -3. So the g function is the pink, evaluated at -3 is going to be -1. Oop, I need ink. So g of f of -4 is -1. Now be careful, the pink function is not defined at -4, but the f function is. So if it had been asking us to find f of g of -4, we would not be able to do that because it's not defined at g of -4. Now we're going to do the last one. So we're going to clear a graph, and now we're evaluating g of f of -3. So first thing we need to do is find f of -3. So f of -3, f is the blue function. So f of -3, go down to the blue function, and it's -2. So now we're going to find g of -2. And now g of -2, g is the pink function. So we're going to go down to the pink function. Whoop. And that's -1. So g of -2, whoop, ink, is -1. So the function f evaluated at -3 was -2, and then g evaluated at that value, g evaluated at -2 was -1. If you have any additional questions on this problem, or if anything needs to be clarified, please let me know.